Hello, welcome to my channel. And let me introduce myself. My name is Yus. I'm from Indonesia. And today I want to explain about how to configuring your publisher nodes, yeah, especially in the node script using C++. And I will break down the basic of publisher, yeah. So in the ROS2, there are concept of publisher, subscriber, and timer, yeah, in the nodes. And basically, in ROS, we're just using a publisher to publish the topics and subscriber to subscribing the topics. And inside the topics, we have a message. Yeah. So yeah, I don't explain about detail in publisher and subscriber, but I want to explain the how to make the whole nodes, yeah, using simple publisher. Okay, don't forget to subscribe this channel and still on uh, this video until the end. We do it. Okay, so let's check the script of the C++ here. So then I have tax1 CPP here, and also we have libraries. Yeah, then we have a class, and then the main function. And the goals of the nodes is a basic ROS2 node written in C++ that publish velocity command in the turtle sim simulator. Okay, so we create the class of drive turtle here, and the name of the nodes is drive turtle. Okay, and these nodes will appear after we launch the turtle sim simulator. And here we have also a timer. Yeah, timer function is periodically to generate the velocity messages. And I will explain the details later. Okay, and the fundamental library that we need to run these nodes of this publisher geometry messages message twist, we must include the library of geometry messages message twist here. Don't forget to put the library of geometry messages and RCL CPP. Yeah, so RCL CPP is the ROS2 C++ API for creating nodes, publishers, subscribers, and the timers. And the geometry messages, this is used for velocity commands, yeah, linear and angular. So if we want to send the velocities to our robots, to our entity, we must need this kind of library. Yes, and then for the class here, drive turtle is inherit from the RCL CPP node, and then we define the constructor here, drive turtle, with the name of the node, drive turtle, with the count of the timer is 0 here, and then the publisher, yeah, the publisher using geometry messages message twist, and the name of the topic is turtle1's mdvel. Okay, then
10, it indicates the message queue size. After we define the publisher, we define a timer and we create a wall timer in 2 seconds. And whenever the timer is tick and the timer callback is called. Yeah, so we move to the private variables here. In the private variables, we have void timer callback. Yeah. So in every time the timer is ticking, the timer callback is called. Then in timer callback, we have the name of variable message with the type of geometry messages message twist. Okay. And this function of the name of the message is to creating the linear speed or the linear velocities of x in 0.5 meter per second. Yeah. And we define the other maneuver for the robots. In this example, the robots will move in circular motion using the angular speed and linear speed, and the angular speed is based on the radius of the input. Yeah. So after that, we use the RCL CPP input. This is for informing in our terminal using the RCL CPP to give the information about the radius and the speed of the robots. Okay. Then in the last part of the callback, we have a publisher here to publish the message. Yeah, publish the message. So publisher will send a message that we have created before in every time timer is ticking. So in every 2 seconds timer ticking, and then the robot will move in circular motion. Okay. And after these methods or this function, we define the timer variable here using shared pointer. Yeah, RCL-CPP timer based shared pointer timer, RCL-CPP publisher geometry message twist shared pointer publisher. Okay, don't forget to put the details of the information of the publisher and timer variable here, and we use shared pointer here. Okay, so shared pointer is using for the efficient management of memories in the system. Yeah, so this is the beneficial of using C++ for the system of robotics. Yeah, and if you implementing the C++ on hardware system using pointer, it's very efficient and real-time and low memory computing. And then we define the others like count and size. Yeah. And the last part of the nodes, don't forget to create the main methods. Yeah, this is very special in ROS2 nodes. Yeah, so the design of the nodes is just like this. Yeah, the first one, you create a library, you import the library here. Yeah, and then you define the class of the nodes using public and private variables. Yeah, and after that you must declare the publisher, subscriber, timer, or some of the public variables that you want to create in your nodes. And in every publisher and subscriber, you must declare the callback. Okay, so callback will be called every time the system is ticking. Okay, so after some of the new steps or the new interval of the time, the callback is called in every steps, and inside the callback is like your logical logical problem solving. Yeah, so the solution of the system is inside the callback function. And the last one is the main method for initialization, spinning, and shut down your nodes. Yeah, your class nodes. For instance, is initialization, spin your class. Yeah, drive turtle for running in the moment, and then shut down if you closed, or yeah, if you turn off the system. Okay, I think this is the explanation of the one example of the nodes that I created for you to understand the simplification of the nodes for ROS2.